Advanced Algebra 2, Concept 10.5 Notes. In this portion of the notes, we're going to explore the method called completing the square, which is another method to solve quadratics. You can use this method with any quadratic equation. So coming back to this graphic from the Concept 9 notes, just looking at the different methods to solve quadratic equations algebraically. So we can solve by using square roots, we can solve by factoring, and now we're going to solve by completing the square. You can see that the next method that we'll learn in our next concept, concept 11, is solve using the quadratic formula. Again, when we're solving, we're finding where the graph of the quadratic, the parabola, crosses the x-axis if it does, and if it doesn't, then we're finding the imaginary roots. So previously we've worked with a single x squared or an x squared expression by taking the square root of both sides. So this method, solving by completing the squared, also works that way. So once we do what's called completing the square, then we can take the square roots of both sides. So what we're looking for is a perfect square trinomial. So this is a quadratic that when you break it down and factor it, it just factors as an expression multiplied by itself. So look at example 1, number 1. It says solve the quadratics using square roots. Factor the expression on the left side of the equal side, and then use the roots to solve. So x squared plus 4x plus 4, rather than moving the 36 over, because it says equal 36, we're going to factor our quadratic on the left side. So we're looking for two numbers that will multiply to give us 4 and combine to give us 4. So 2 and 2. So that means it's a level 1 factoring, so it will break down as x plus 2 times x plus 2, and that will equal 36. Sorry, that's my dog. We can write that as x plus 2 quantity squared. So now see, x squared plus 4x plus 4 is a perfect square trinomial, because it has the factor of x plus 2 squared. Just like 4 is a perfect square, it has a square root of 2. X squared plus 4x plus 4 is a perfect square trinomial, and it has a root of x plus 2. So now we can just take the square root of both sides and solve like you've done before. So x plus 2 equals 6 and negative 6. Subtract your 2 from both sides. So x equals 4 and negative 8. Let's do the same on number 2. So x squared minus 6x plus 9 is a perfect square trinomial, because when we factor it, the numbers that will multiply to give us 9 and combine to give us negative 6 are negative 3 and negative 3. So just negative 3 squared. So it will factor as x minus 3 quantity squared, and that will equal 1. Now we can take the square root of both sides. X minus 3 equals 1 and negative 1. We need to add the 3 to both of those values. So x will equal positive 4 and x will equal positive 2. Now number 3, let's do the same thing. So x squared minus 22x plus 121. That, believe it or not, is also a perfect square trinomial. So negative 11 times negative 11 will give you 121, and if you add it, you get negative 22. So it factors as x minus 11 squared equals 81. So we take the square root of both sides. X minus 11 equals 9 and negative 9. Add our 11 to both of those answers. So x equals 20 and x equals 2. Sometimes we'll have a trinomial, that is not a perfect square trinomial, but we can create a perfect square. So the way that we do that is that we pick out our a and b value, and then if you take half of the b value and square it, that is the number that will create a perfect square trinomial. I have a graphic over on the right that you can look at, and when we're in class, we'll look at it more about a visual representation of completing the square. What we're doing now in these problems is we're completing these trinomials so that we have a perfect square. So on number 4, our b value is 6. If we take half of that number and then square it, that's 3 squared, or 9. So the number that will make this expression a perfect square trinomial is 9. And then look, because what two numbers multiply to give us 9 and will add to give us 6? 3. 3 and 3. And so we can factor it as x plus 3 times x plus 3, or simply write it as x plus 3 squared. Now on number 5, locate your b value, which is 14. If we take half of that, which is 7, and square it, we get 49. So that's the number that gives us a perfect square trinomial. It completes the square. So that means that we can factor it and as a number multiplied by itself. So 7 times 7, if we multiply, we get 49, and add, we get 14. So that factors as x plus 7 squared. We can even do it when we have a fraction. So their b value is -5. We're going to take half of that, which is 5 halves, and square it, which is 25 fourths. So we're going to leave it as a fraction. Now we're looking for two numbers that will multiply to give us 25 fourths and add to give us -5. That will end up just being half of the b value. So x minus 5 halves. Think about it. If you square -5 halves, you get 25 fourths. And if you take -5 halves and add another -5 halves, you get -10 halves, which is -5. So this is how we complete the square to make a perfect square trinomial. Now we're going to use that in some problems to help us solve quadratics. So we need to solve x squared minus 10x plus 7. Right now this cannot factor. We do not have a perfect square trinomial because there are not two numbers that will multiply to give you 7 and combine to give you -10. But we can create a perfect square trinomial and then move forward. So if you look at the steps, the first thing we're going to do is to add our current c value over to the other side of the equal sign just to get it out of the way. And then I'm going to leave some, so I'm writing the problem. Now I'm going to remove my 7 over. Notice I leave some space in that position where 7 was, so I can complete the square and put my number in to make a perfect square trinomial. My b value is -10, so I take half of that and square it, which will give me 25. Then I'm going to add the 25 in to make a perfect square trinomial. But I have an equation, so whatever I do to one side, I need to do to the other. Now I have done steps 1 and 2. I need to talk about step 2. If a does not equal 1, then we need to divide all terms by a. But our a value did equal 1, so we did not need to do that. Then we completed the square, step 3, and now we're going to factor the left side. So a number that will multiply by itself to give us 25 and combine to give us -10 is -5 times -5. So this factors as x minus 5 squared equals 18. Now I bet you know what to do. You just take the square root of both sides. X minus 5 equals plus or minus 3 times the square root of 2. Add your 5 over and we'll just put it in front of that expression. So our two answers are 5 plus 3 times the square root of 2 and 5 minus 3 times the square root of 2. Let's try another one. So we have 3x squared plus 12x plus 15. We are going to move our 15 over, subtract it from both sides. Now we're going to complete step 2. Notice our a value is not 1, it's 3. So we are going to divide everything by 3. So when we're solving, we divide that number out. Now we can take half of our b value and square it. This method does not work unless our a value is 1. So we need to add 4 to both sides. And then we're going to factor our quadratic on the left side. So two numbers that will multiply to give us 4 and combine to give us 4 are 2 and 2. So it will factor as x plus 2 quantity squared. And that equals -1. We'll take the square root of both sides, so x plus 2 equals plus or minus I, and then we'll add the 2 to both sides. Sorry, we're subtracting the 2. So x equals -2 plus I, and x equals -2 minus I. Let's try another one. So we're going to do something a little different though. Rather than solving, we can use this method to take a quadratic that is in standard form and to rewrite it in vertex form. So what we do is that we keep our y value in the problem. So we do y equals x squared minus 12x plus 18, but we go ahead and move our c value over to the other side. So we're going to move our 18 over to join the y. So we get y minus 18 equals x squared minus 12x. Now, if our a value did not equal 1, we would factor that out. We will not divide it. Notice we're going to factor that out. But our a value in front of the x squared is 1. So we can go to step 3. We're going to complete the square. So we'll take half of our b value, which is negative 12, divided by 2 is negative 6, squared is 36. Now we're going to add that 36 to both sides. And then we're going to factor the side on the right and simplify our side on the left. So y plus 18 equals two numbers that multiply to give you positive 36 and combine to give you negative 12 is negative 6 and negative 6. So the right side factors is x minus 6 quantity squared. Now, do you see vertex form emerging? We're just going to subtract the 18 over. So we get y equals x minus 6 squared minus 18. That is vertex form. And now we can identify our vertex. It's our h and k. Remember, h is opposite sign, so positive 6, negative 18. Let's use this method now in this problem. So the height y in feet of a baseball, t number of seconds after its hit, can be modeled by this function. Find the maximum height of the baseball. Well, you know that means we need to find the y value of the vertex. So let's rewrite this quadratic in vertex form by completing the square. So the first thing we'll do is we'll subtract the 3 over. Now notice our a value is not 1, so we're going to factor out that negative 16. So we'll get t squared minus 6t. Now I'm leaving a little space within that parentheses to complete the square. My new b value is negative 6, so I take half of that, which is negative 3, and square it, which is 9. Now you think, oh, well, we just add 9 to both sides. But technically, we are not adding 9 to the right side. We are adding 9 times negative 16. So that's what we need to add to our left side, a negative 144. So we complete the square by putting our 9 in, and then we add our negative 144 to the left side. Let's simplify. Y minus 147 equals negative 16, and let's factor. The numbers that multiply to give us 9 and add to give us negative 6 are negative 3 and negative 3, or t minus 3 squared. Now, do you see that we're almost to vertex form? We are simply going to add the 147 over. So negative 16t minus 3 squared plus 147. We know the vertex, and now we know the maximum height of the baseball. So after 3 seconds, this baseball is 147 feet high in the air. How long does it take to hit the ground? Well, you may be thinking, let's just double the time to 6. But this ball was not hit from the ground. It was hit a little bit off the ground. So let's figure this by plugging in 0 for y. And let's see where the ball hits the ground when the height above ground is 0. So let's move our 147 over. And then let's divide by negative 16. So t minus 3 squared equals 9.1875. Let's take the square root of both sides, and we're going to estimate since it's a real life problem and we want seconds. Okay, so technically it's positive and negative 3.03, but we just want to know when the ball hits the air in a positive time, and that's 3.03 seconds. So we have 0.03 of a second more to account for the fact that the ball did not leave from the ground. So if we add the 3, that means the ball hits the ground at about 6 3/100 of a second. All right, that completes the notes for completing the square solving quadratics using that method, concept 10.5.